We are Manoj Pandey, and introduction to web scraping using Python. Thank you.
Am I audible at the back? All right. So I hope you had a great lunch. I'm Manoj, and I am traveling from India. I'm the organizer of PyData Delhi, and I run a community over there. But I am a computer science undergrad, and I do various stuff in research and privacy and online privacy and security and online social networks, some programming and design. This talk is about an introduction to web scraping using Python. So even if you are a complete beginner to Python, this talk will actually teach you something. And if you have like some doubts regarding like what web scraping actually does to you, so you're going to learn something. So the agent of the talk is what and why about web scraping versus APIs, the various libraries available out there, which library to use for which kind of job, and there's a particular web framework called Scrapy, so we're going to discuss a bit about that, and when not to use particularly Scrapy, and a lot of other stuff as well. And finally, we'll talk a bit about legalities, because I actually had a couple of questions in the last talk. So Mitchell Kaper is the guy behind Mozilla Foundation, and he said that getting information off the internet is like taking a drink from a fire hydrant, which is absolutely true. So in today's world, I think like almost everyone is in dire need of data, and they need to have the data in some or the other format. And mostly, we consume data over the web, and if the data is coming from the web, then we need to like get it somehow. So I think like the first way that people could actually think of getting the data from the web would be like manually, like opening the website and trying to see what data there is and trying to get it locally on your system, like trying to like type manually. But that's going to take a lot of time. You can't do a million web pages on your own. So you need to have some process you can use and get the data automatically. So web scraping is a technique for gathering the data from the web pages. So let's say on the left you have your websites, which are basically containing HTML pages. So all the data is like semi-structured, maybe unstructured, or display. And you just get the data to have it in a form that you could actually access it more properly. Let's say throw it in a database, so you can filter it, you can run some search queries and everything like that. So in that way, you can actually use the data right now. So we're going to learn more about the process in between the data on those websites versus and the data that you get after scraping from those websites. So there are two things, like when you talk about like getting data from websites. So sometimes you see there are static websites which just display the content, but sometimes there are websites like Twitter. If you open Twitter, you will see that the data is like coming live, and if you keep the tab open for a little bit, you will see more data coming. So it's basically like it's some dynamic thing happening on the web pages. So it's something called like Ajax or like JavaScript behind the browser. So we have like a certain APIs. Every website actually gives you some sort of access mechanism to get their data from their databases. But the thing is, like when you are trying to get the data from their databases, they won't actually allow you to get all of it like really quickly, because it's basically a hurdle for them to open the database publicly, like for every request every second. So they do something which is called rate limiting, which actually stops you from getting the data so quickly. So it might be something like Facebook does as like 6 requests per minute or something like that, and Twitter also has their own mechanism. So every website tries to enforce their own API limits, which you have to obey. Otherwise, you won't be getting the data, and it will show you some error. But the thing on the web is, if you can see it, you can actually get it. So how data comes to these web pages? So every data that you see on the web pages are basically HTML pages. So if that's an HTML page, and if you can find a way to get that HTML data to your local system, then you can do some mechanism to find the data that is useful to you. And you can use it. So we use web scraping, and we find web scraping in real life with a lot of examples like product information job posting, internships, movie listings, and anything like that. Extract data to make a search engine, weather data. So we have it almost everywhere. So the advantages of web scraping using versus an API is web scraping is not rate limited. You can't, so API actually has a rate limit, but web scraping doesn't have it. You can anonymously access the website and gather the data, and some websites don't even have an API. So what can you do with those websites? So the only way to get the data from those websites is just scraping the data. And some data is not even accessible through an API. Let's talk about Instagram. So Instagram actually gives you an API, but it just allows you to get your own public data. And if you want more data of like public hashtags, you have to send them a request to get you more API endpoints, which is a bit difficult. And there are many more examples. So how web scraping actually works. So the first step is to get the website. It's just basically using any HTTP library, which we'll talk about. Then when you have the HTML document, now you need to just parse it. So by parsing, you mean so every HTML page is in sort of some tree. So we have some tools which you can actually use to get the data in a particular format. So you can just iterate through the entire tree and search for a particular tag, let's say A tag or P tag. Then finally, when you have the data, you just have to store it. Maybe it might be JSON, it might be a text file, a CSV file, or maybe you can just build some pipeline so that entire data that's being collected goes into a database. So we're going to focus more on parsing. So that's the entire concept of web scraping. So there are a couple of libraries that are available in Python. So the most famous ones are Beautiful Soup, LXML, regex, Selenium, and there's a web framework called Scrapy. So let's talk about all of them one by one. These are the HTTP libraries. Request is the most famous one. When we have URL lib2, HTTP lib, HTTP lib2. We also have the URL lib3, which actually was used to build request. And the way you have to get the pages is pretty easy. You just have to send in a GET request and the URL of the web page, and you just parse the HTML. So you just have to go through the documentation of how request works, or maybe URL lib2 or URL lib3 works, and you just get it. So I think these are pretty easy. This is a pretty easy process because this is just one line. You send in a GET request, you get the response, and you save it in some object, a Python object. Then you have to parse it. So for parsing, we have these libraries, Beautiful Soup, LXML, and regex. So let's say if you have to use Beautiful Soup, we make some soups, which is not actual soup, but it's the way the Beautiful Soup parses the entire HTML document into a tree format, which is the same for all of them. LXML also does the same thing. And regex, if you might have used in any other programming language, so regex actually regex actually works on the basis of patterns. So you give it a pattern, and then you actually find what pattern are being matched in the entire document, which is actually really quick. But at the same time, it becomes tedious as the web page becomes larger and larger, and the number of tags in your web page gets larger. So Beautiful Soup, pretty easy. You create a tree, and the HTML document which you got from the last step, you just have to pass it here, and then you can get anything. Let's say the title of the web page, tree.title. And then LXML is also pretty similar. Regex is also pretty similar. So this is really small code snippets. Let's talk about Beautiful Soup more. So it has a really beautiful API. It's probably one of the easiest tools that you can learn in just 1 hour. It's really simple. And you just have to create, you just have to parse the entire tree. And it can also handle broken markup, because you might have seen on websites that there are times where the markup is not proper. Let's say there's a title tag, but the title tag is not closed, something like that. Beautiful Soup is purely written in Python, and it's a bit slow. It doesn't have its own parser, but it actually uses an external parser. LXML actually is much faster, because they have this C bindings built in. It's not, so we can't say it's purely Pythonic, but it does the job pretty well. It's really fast just because of the C bindings, and it works with almost all the Python versions. So regex is the regex library for Python, and it's used to extract minute amount of text. And you just the only learning curve is to learn how regex actually works. So if you know how regex works, then it would be pretty simple. but that learning curve sometimes becomes a bit tedious, so that's why regex becomes complex. And regex is also purely baked in Python. It's it's a part of the standard library, and it's much faster than LXML as well, which we'll see, and it also supports every Python version. So regex actually becomes tedious. Regex is actually really easy when you have just like simple URLs, and you just need to find, okay, this kind of URL and show me where this URL exists in the entire page. It's really easy. But if you have something like find all the URLs within the A tag with the class mylink, and get a list of them, so it becomes really hard using those regex thing, because you have to like create your entire regex, and it might happen that it's working for a couple of links and it's not working for other ones. It might give you like false positive and so on. This is a very small comparison. I hope I can scroll it. So I just create a function for Beautiful Soup, for LXML, and for regex, and I just send in an URL, and I just extract the URL, the content of the URL, and I try to like parse it, and then I try to like time it. So if you can see, the Beautiful Soup is taking approximately like 1800 seconds, and it's probably more than like 32 times faster than regex, and Beautiful Soup is taking 245 times more than regex. So you can see regex is probably the faster, but as this is a really small example, we are not doing any complex stuff, so that's why regex is actually working pretty good. So the next step is, what if you need like massive scraping? Because it's not like you will be just getting one web page. Let's say you need to get some data from Amazon, and you need to get all the product listings on Amazon. Although it's a really hard task, but because Amazon has like thousands and millions of pages. So if you have a requirement where you need to like scrape millions of pages, and you need a really large web scraper, or you need to like build a lot of them, or you need something which is robustly tested, because when you create a Beautiful Soup script, it's not, you're not doing any testing or something like that. But when you're using Scrapy, it has all the tests and everything is functioning. So it's a more robust thing. So for this thing, we use Scrapy. So there are some advantages of using Scrapy. The first thing is really fast. It actually uses Tornado at the backend. It's fully blown and thoroughly tested, and it's really asynchronous because it has the Tornado at the backend, which is used for async programming. It's really easy to use. It's really customizable. You can actually bypass all the default attributes in Scrapy. You don't have to worry about anything, and you don't need to reinvent the wheel. So let's say cookie handling and exception handling is already there in Scrapy, so you don't have to worry about that as well. And it's purely in Python, so it's supported by Scraping Hub, which is associated with PSF. So the requirements are when you have to scrape millions of pages, when you want async support, because Beautiful Soup, LXML, and these things are not asynchronous. Although you can use libraries like async.io to perform the same task, but out of the box, they're not asynchronous. And when you don't want to reinvent the wheel, let's say cookie handling and these kind of things, so it's like pre-built, inbuilt in the Scrapy framework. And when you're not afraid to learn something new, actually. So let's talk about the simple workflow in Scrapy. So you first define a scraper, then you define the items that you want to extract from a particular website. Then you define your items pipeline. So what items pipeline does is actually extract all those items, and you have a pipeline through which those items go and get stored into a database, or maybe some JSON or something like that. And then finally, you run the scraper. So let's start with this really small project. So Scrapy has this command line utility, something like Django and other projects. So you just do Scrapy start project and give it a project name like PyCon, and it actually gives you these files, your configuration files, your items file, pipelines for database, your settings file, and your spiders. And you can have more spiders. I mean, you could actually build more of them. So items are containers that will be loaded with the scrape data, and if you have a items pipeline, that entire data goes to a database as well. So they work like simple Python dictionaries, but provide additional protecting against populating undeclared fields to prevent typos. So to declare an item class, it's pretty simple. You create a class, and you use your attributes that you want to extract from that website. Let's say I want to get the title and the link, so it's a Scrapy field. It's a descriptor actually, and then you give the description. So these three are the things that I'll be extracting from a particular website. Then this is a really small website which so this is the website. It has a lot of these articles. So I'm getting there's some problem. Okay, there you go. Yeah, so if I go to this URL, it's actually the same URL. So you have these books and their titles and their descriptions. So these are the three things which we have defined in our items pipeline. And then, yeah, so Scrapy has a inbuilt feature called a Scrapy shell, which you can actually directly use. So you can just call Scrapy shell and the URL of any website, and it actually gets the data and gives you some basic methods to, basic functions to actually access the attributes. Then you can have all the selectors. So all the selectors are already present. So in HTML, you have, in CSS, you have different selectors like XPath, and ID, and this class. So everything is inbuilt in Scrapy, so you don't have to worry about it. You just have to use them. So let's say I generally use XPath because it doesn't creates any conflicts. So so you just pass the XPath, which you have to find out from your developer tools. That's the thing that you need to do on your end. And when you have your XPath, you just put it here, and you can just find whatever data that you want to get. Then your Scrapy item. So it's just a small class, and we have the start URLs, which I'll show you right now. Yeah, this one. Yeah. So I have the name of the spider and the allowed domain. So domain is basically the name of the domain which I'm actually using to scrape the entire data. And the start URL. So the start URLs basically tells you which URLs you need to get from this domain, because a particular domain, if you try to traverse the entire the entire URLs associated with that particular domain, it's going to be like many of them. So if you need that, you just need to like scrape the data from these 2 particular or like 10 particular URLs. You just have to like list all of them here, and then you create your parse method. So the parse method is basically it's actually should be in sync with the data that you are actually defining in your items. So we had like 3 things: the title, the link, and the description. So I send the selenium selector.xpath and the xpath of that particular title, which I got from the developer tools, and then I just yield the item. Oops. And then I just crawl the data, and then you have like 2 choices. So when you start your Scrapy crawler, so you just have to give a name, something like demos. So in my class, the name is demos. You might be having like more than one spider to get a particular data from a website. So let's say a website has like different sections: books, references, movies, and you can have like different spiders for a particular website. So you can have like different names, and for every name you can actually call the Scrapy crawler. So Scrapy crawl and then name of the crawler, and then you get the data, and you have like 2 things two ways to store the data. One is the feed export, which is inbuilt. So you just have to send in a command, something like this, like Scrapy crawl the name of the crawler, and then output to items.json. So all the data that's been collected by the crawler, that it directly goes to this items.json. Otherwise, you can actually define your items pipeline, and let's say generally I use like MongoDB, because this kind of data is actually doesn't have most of the time doesn't have any relations. So I don't actually need a requirement of having a SQL database or something like that. So Mongo works pretty good. So you can use like PyMongo, and Scrapy actually has the extensions to use that. So you just have to fill your items pipeline, and all the data that comes through the pipeline, instead of going through the feed export, goes through your database. So when not to use Scrapy? So basically libraries like Beautiful Soup, LXML, and regex, they're actually pretty easy to use. You can just like sit for like 15 minutes and have a small website, and you can make a beautiful BS4 script, which would be something like 20 lines or 30 lines, and you'll be done. But the thing with Scrapy is you will be using Scrapy for scraping huge amounts of data. Let's say if you want to like crawl all the questions on Stack Overflow for at least like 10,000 pages, it's going to be huge. So it's much more robust to do that, but it's going to take a bit more time. So don't use Scrapy if you're just building a small script, which is just taking like 20 lines. You can actually do it with Beautiful Soup, and you don't have a really strong requirement of time and these kind of things, and processing as well. So if you want to like crawl a small number of pages, if you want something really simple, and you want to reinvent the wheel and you want to learn the basics. So now we have talked about a lot of things. So you might be like wondering like what library I should use, because there are like lots of them, and these are like just a couple of them. And people have built like tons of libraries just for web scraping. So if you need like simple extraction, not extraction from a big web page, just use regex. It's really simple, but it will just work for a small use cases, not for really large web pages, because the reason we have already discussed. If you want to extract a lot of data and do not have a pure Python library requirement, then use LXML, because they actually interact with the seed bindings, and it's relatively faster. And for broken markups, yeah, Beautiful Soup actually handles broken markup pretty easily. And if you have to like scrape a lot, just try to go with Scrapy. So you need to see for yourself the time versus the speed trade-off, because Scrapy is going to take a bit more time to build the crawlers, the spiders, and your items. But Beautiful Soup is just going to take like 15-20 minutes. And you also need to like check the library support, the community support as well, because you might be using BS4 or LXML, which is relatively easy. And if you like find for solutions or maybe for some help over the internet, it's relatively easier to get some help. But Scrapy, if you go even to the mailing list, it's really hard. So sometimes you might be like stuck for a long time. So you also need to like check those kind of things. So the final thing is about the legalities. So basically, scraping in general is a really gray area. So people have different notions when we talk about legalities. But at the end, it just depends on how are you going to use your data. So it might happen that you have your own personal website, and you just want to like learn how scraping actually works, and you need to like scrape the data from your own website, which is pretty perfect. Anyone can't raise any issue. But let's say so every website has a file called robots.txt, which they actually fill with some information for crawlers. So you actually need to obey those rules. If they are telling you that don't try to access this particular URL, so ethically you shouldn't do it. So, and some websites like prohibit scraping, so they have written it explicitly in their robots.txt, and that's it. So thank you so much, and I thank GitHub and NumFocus for supporting my travel for here, and a lot of other people, my friends, supporting me, and that's it. Thank you.
Okay. Thank you very much. Any questions?
Does Scrapy support Python 3 or is it 2.7 only?
Scrapy?
Yeah.
It's both of them. Yeah. Yeah, true.
Sorry, if page is dynamically created through JavaScript, is it possible to use Scrapy as well, or just work with plain HTML?
So, right. So this is a really it's a pretty common thing that happens with most people, and happened with me as well. So with dynamic pages, using Scrapy, you're pretty good. But if you think that you want to do the same thing, you want to mimic that the page loading and the network calls. So what you can actually do is just open the developer tools and let's say take an example of a website where when you hit the scroll, you create a jQuery scroll event and it triggers a next request and fetches some data and puts into the DOM. So if you can figure out the network call, which is not really hard, you just have to go to the developer tools and get that particular network call. You just have to mimic that thing. That's it, and you're done. So that's probably something which most of the people get stuck at, because normally, like with static websites, it's really it's really easy. But with something like maybe even Twitter, because Twitter has a limit that says you can't actually get more than 3,200 tweets from a personal profile, and there are like thousands of people with more than 3,200 tweets. So that's actually a way to do that. Yeah.
Okay. Another question?
And what about login protected pages? I didn't see something.
Yeah, so I think like I missed one thing. So okay, that's okay. So in the beginning, I talked about these 5 things. So Selenium is a thing that can actually handle that thing for you, because so Selenium is a automation tool which actually is not built for scraping, but you can actually use it for scraping. So how Selenium actually works is it creates a new browser instance. Let's say you're using Chrome or Firefox. They have their own drivers, so like Chrome driver and Firefox driver. So you just use Selenium and it pops up a new instance of Chrome, and you just have to go through the web to that particular website in the same way you do it manually. So let's say I probably can show you. A friend of mine actually built something that most people use WhatsApp. So WhatsApp has a browser, a browser way to send the messages as well. So let's say if you want to like spam your friends, I mean you can't do it with hands, and it's really hard to do something with Android. And when you have the web, and when you know something could be done, using scraping or maybe automation, so you can use Selenium over there. So you just have to. So Selenium has a Python library as well. So it's Python Selenium or something like that. Pip install Python Selenium, and you just have to put in the URL of that particular web page, and you just have to mimic every single thing that you actually do with your hands. So let's say if there's a website which actually allows you to feed something through a drop-down list, so you have to like click on that list, then go 8 rows down, then click on that button, and then search for it. Then you get a new web page. Then you click on something and it opens up a pop-up. You switch from your previous web page to that new window. So entire thing can happen with Selenium. So I've done this thing and it works pretty well. The only drawback with using this thing, it's really slow, really slow, because every single action is happening on your browser, and it might happen sometimes that you're using a really slow laptop or slow desktop, and it also affects these things. But yeah, every single instance and every single web page being loaded on your browser, it's going to take like a lot of time. So I personally know that there was a time like 2 years back I had to like scrape something which was just like 100,000 records from a file, and it took me like 6 hours, because at that time I never knew about like Beautiful Soup or this JavaScript thing. So I had to just use Selenium, and I waited for 6 hours in front of my laptop. That was the only thing. That was crazy.
Okay. Another questions if you want. Okay.
Why Beautiful Soup is better for broken markup?
Is better for what?
Broken markup. No, so, markup.
So, broken markup.
Yes,
so,
you said that.
Yeah,
Why?
Yeah. So basically, Beautiful Soup has so the way Beautiful Soup is internally made up to make the tree. It actually checks for whether a tag is present or not. If it's not present, it actually adds a tag. So even if you don't have, let's say, a p tag and an ending p tag, or maybe a title tag and an ending title tag, so it will just fills all the information for you. So you are pretty safe over there. Yeah.
Okay. The time for the last question.
Does Scrapy supports scraping scripts? Like go to that page, collect the links, and load the other pages and collect the data from that.
So you saw this thing. So this one, right? So you can actually state what URL you need to start, and it will actually go through all the URLs from starting from that particular URL. So let's say like book/1, book/2, book/ yeah, exactly.
Okay, thank you.